Hello YouTube, this is Advanced Tech Engineering again. We said we were going to show you how or explain how to run the little Geo we have on this system, and for those people who haven't seen it, I'll go over the setup real briefly. And right off the bat I want to say this thing, it's been producing approximately 12 liters a minute, which is just under what I need to run the Geo. So the Geo is going to run like crap once it switches over to hydrogen, and also I have the timing set at top dead center, so it's also going to run like crap on the gas. So I'll show that timing and whatnot in a few minutes, but for now let's go over the system. This is our new type of cell, and we still build brick cells as well, but these cells are better. So what we have now is this top portion is the cell, and there are plates in here within another tube. There's 100 plates, and we're going to be running over 200 volts on this cell, which is that's what it's built for. Below here is just the water reservoir. We use a different chemistry than other people as well, so it's a new thing we've been doing. And anyway, this is our new bubbler, the Advanced Tech's new bubbler, and we have a new website also, and it's advancedtecheng.net, and we still have the other website as well, and it's going to be converted to the new website, so eventually you'll just see the new website we have there, and all of our new products are on there, and we've revamped them, and they're different. So we got a power tab over here. You can see the water level here never really fills up all the way. It'll cascade over into this outer tube from the inner tube. We got a water inlet on each side, and then we have the drain, which drains back into this lower tank on the other side. So we have these three drains, and then of course another power tab, and our hydroxy out is in the top, and we have a drain on the bottom here for the water tank. And this little pump here is a diaphragm pump. It's going to be circulating the water from the top to the bottom, and you'll see that happen. We have a hydroxy flow meter, and it goes to 20 liters a minute, but like I said, we're going to be flowing around 12 liters a minute, and we're going to be powering this system off of our power supply, the Advanced Tech Engineering's power supply here. And what we got right here, this is going to be running the 12 volt pump, and over here we have, this is 12 to 36 volts on this side. This is 12 to 16 ish on this side, and this power supply has an input for 110 and 220 at the same time, so we get a lot of power. And on the 110 side I like to run this variac so that I can change the voltage on the low voltage side to be more what I want it to be. And we also have two high voltage outputs. These will do 110 and 220, and you can run 110 on one and 220 on the other. You can flip the switches to get any combination of the two. And these amp meters that are on here are only accurate down to a whole number, so they don't do any decimals. They round up or down, but they're accurate within to a whole number. And I'll show you the power output here, which you can do the math to actually figure that out. You'll see that it takes quite a bit of power to do this. We do build these power supplies if anybody wants one. They're not cheap. This power supply is approximately $2,500, and it is a very high quality power supply. It has 6 heat sinks. There's 3 on each side, and 2 big fans that are in the back here that you might be able to hear. So it's a very powerful power supply. And then, so these 2 little jumper cables here are just connected to the pump, and that's what you saw on the other side was the low voltage. And these 2 bigger wires were connected to the 110 or 220. There's one of those on each side again. You can see them right there. And then we got our output is the screen hose, and I'll show you. We're going to come over to the Geo here, and we're going to be ported right into the throttle body. This is not this is throttle body injection. and right there is a flashback arrestor. We don't recommend using your bubblers as your flashback protection. Those bubblers are scrubbers for us. They get rid of unwanted gas created by the hydrogen or electrolysis process. So last time you saw this geo run, it was a little more complicated. We had some CNG stuff on this throttle body, and there was a lot of questions. So what we've got now is a very simplified version. Literally, this hose just goes right in there and right down to the butterfly flap that controls the air intake, and that's it. So there isn't much to question here. There's nothing in the way of anything. So we're going to show the timing on this, how it's set up right now, and these two valves here are to turn the gas on and off. One's the return and one goes in. So we're going to turn them both off, so there's no confusion on that, to show that this will kill the car. And then we're going to also show the timing, which will be shown down there, and I got a timing light. So that being said, we'll go ahead and start the engine, and I'll show the timing. Now remember, the timing is at top dead center, so this runs terrible, and we'll show you. I don't know if you can see that. So there's the timing. There's a 0 there, and the white mark is on top dead center. Let me zoom in there if I can. I don't know if you can see that very well, but anyway, we are at top dead center. And now I will throw these switches here so you can see that the car will die. It'll take a second. Longer than I thought. Okay, car's dead, so those two switches kill the car. So go ahead and start the car again. And there's some people who say you can't run a car at top dead center on gasoline. That's a bunch of crap. You can start it and run it. However, if you drive it, it'll drive like crap. It'll have no power. So the car is now running again, and now we'll go ahead and start the hydroxy system. And I'm gonna turn the pump on, and I'll try and show you the water in there cascading over, but that is also shown in another video how this setup works. So if I don't catch that, then you can look at the other video. So I turned the pump on. That's the voltage on the pump and the amperage. So you can hear the pump running. There's no hydroxy coming out yet. It's not on yet. So we're recirculating. It's pushing and pulling water from the top. You can kind of see it maybe cascading over in there, the water. Okay, so now you'll hear a change in the engine when I flip the switch for the hydroxy on. And we're bubbling. And we're flowing. So we're flowing just almost 12 liters a minute. Now the engine has started to run very smooth, and that's because we've added a fuel that is meant to burn at that top dead center. However, we don't have quite enough, so the engine, when I turn these off, is going to run terrible. So I'll turn them off now. And it's having a hard time, but it will continue to run, just barely. So we need just a little bit more hydroxy, which is easy to get. I'm just using this cell to demonstrate that this can be done. And what we're doing here is just demonstrating how to make your own fuel and how simple it is to use. This is not anything special. So now I'm going to go over to the hydroxy machine. I'm going to turn that off, and I'll kind of face the camera over there so you can see that it shuts off, and so does the car. and car is off, and the bubbles are dying down. So that's all there is to it. You need just a little more hydroxy, which with a little bit bigger plates we can get. And what I want to do now is actually show, because there's a lot of questions like, okay, I've looked up on YouTube a lot and seen people try and run small generators, and people have a hard time doing it, and you're like, well, how can they? I'm going to turn the pump off here so we get rid of some of this noise. Like, how can I run this little Geo this easily, and it's really easy, while somebody else has a hard time running a little tiny generator? And I'm going to show you a little bit of the math that has to do with volume, just volume. So here's some specs on a generator. This is going to be an 8,000 watt generator specs with an engine size of 0.407. Okay, so that's a generator I have tried to use in the past to do the same thing as everyone else. Okay, so the problem is this generator requires this RPM to run. Okay, 3,600 RPMs. Now, most generators, all of them that are gasoline or petrol, need the 3,600 RPMs. The reason is because that is where they develop their maximum horsepower, and that's where they're rated to get you this 8,000 watts. So if we go off of sheer volume, if you have 0.407 liters of engine size, and you are running that at 3,600 RPMs, that means you are going to draw in, let's see, I have my notes here, we're going to draw in 1,465.2 liters, okay? And that's RPM, so rounds per minute. That's how much you're pulling in. That's a lot. And this is just volume. This is just a volume. This is not how much fuel you need. This is just simple volume. This is not taking in the 14.7 to 1 fuel ratio for fuel, or 36 to 1 for hydrogen. Okay, so now let's see the Geo specs. So the Geo, I'm gonna go off of what it actually is. It's 0.998 liters. Okay, so, and I am idling at roughly, I'd say 600 to 700 RPMs. Whoops. Never mind my handwriting. I write like crap. Okay, so the volume at 0.998 liters at, let's say, I don't know, 600 or so, is going to be roughly, you know, under 600 liters, right? So it's going to be 598.8. Dang. So liters of volume. So just by looking at those numbers, you can tell that to do what I'm doing, I need a lot less fuel. That even if you take in account that hydrogen, you only need 36 point something, I can't remember what it is, to 1. So you need a lot less hydrogen than you do petrol to run an engine. And I've got way less RPMs. I mean, I got almost 2.5 times less RPM or volume than this one because of the RPM that I'm running at. So I see a lot of people struggle with this. They're like, well, how can you run a car when I can't even run this tiny generator? Well, even though this generator is less than half the size of the Geo's engine, I don't need 3,600 RPM to idle the engine. So it's simple. The math is simple. So let me wipe this up. So when people say, oh, I can't get this to run, well, there's two problems. There's the volume problem, and there's also the timing problem. See, hydrogen runs much better with a timing of top dead center because it has a much higher flash rate or flame speed. It's 40,000 feet per second, as opposed to petrol, which is 4,000 to 5,000 feet per second. So you got you can run it at top dead center, no problem. Now, you should always use a flashback arrestor. Let me see if I can find you the name on this one, and if you can. Oh wow, there's a glare. I don't know if you can see it. But anyway, this is a flashback arrestor that is rated for hydrogen amongst other gases, and I recommend using one of these over somebody's homemade flashback arrestor. I mean, this thing costs you about $65, and you will never ever have to worry about blowing up your bubbler, which is basically a hand grenade just sitting there if you're using it for that purpose. It's dangerous, so don't be stupid. Get yourself a flashback arrestor that's tested by a name brand company, and don't be cheap, because you'll regret it. They make stainless steel flashback arrestors, only they cost like $350. It's a lot more expensive. So the brass one's just fine. Let's see. There's another thing I wanted to cover about running these engines, but I don't exactly remember what it was. I try to get everything I can in one video, but it's hard to remember everything. But this setup, I go over it a little better in another video that I recently posted, and it's been a while since we've shown the little Geo there running, and I wanted to make another video simplifying the hell out of it, just so there was not so many questions. You can most definitely run a CNC or a CNG setup on your car and use hydroxy into the CNG system and still run on gasoline, and then tune your gasoline down. Would be a very effective way of using this system. You use them together, and it's a little more complicated to do that because of the CNG stuff. Is people don't seem to get it. I don't understand why not, but anyway, there's a better way for trying to run an engine. Actually, is a diesel engine, and we go back to the volume the gasoline engines need to run, which is 3,600 RPMs is a nominal for a horsepower output for a lot of vehicles, and most of the time it's higher than that, 5,500 RPMs, and a diesel engine only needs 1,800 RPM. So a lot of people struggling with, why can't I do this? Well, the problem lies here within and how the generators are designed. And I'm talking about electrical generators, not this hydroxy generator. They are designed to consume so much fuel at that RPM, so that you are going to have to put a lot of fuel in there, or a lot of hydrogen in there, if you want to maintain that RPM, where a diesel generator runs at 1,800 RPMs, half. So it's a lot easier to obtain that, because now you don't have so much volume going in. And if we were just to convert this engine to a 1-liter diesel engine, I'd get 100 miles to the gallon, no problem, just running on diesel, because diesel engines are almost 50% more efficient, simply because they have twice as many hydrocarbons in them than petrol fuel does. So there's more energy in there, and that's why you see 18-wheelers that are diesel engines driving down the road, not gasoline big 18-wheelers driving down the road, because they'd probably get half a mile to the gallon. So they run on diesel. So what you have to do, if you want to make a self-sustaining system, is you need to get a generator, and this is an electrical generator that runs off of a low RPM and produces a high output, such as a wind generator, which runs approximately 250 RPMs but puts out 30,000 watts. Granted, the torque is still the same that you need. However, you can run your diesel engine at a much lower rate and they put out a lot of torque, so you're going to be more energy efficient that way. So anyway, here's this a little tidbit, you know, from Advanced Tech Engineering, kind of showing some of our new stuff. We use this power supply for testing. We'll build them on request, but like I said, they're expensive and a lot of people can't afford to spend that much on a power supply, but we needed something we could test things and test multiple things at once, and that's what we got. So we built it and now we have one. So we will be releasing some more information about these cells and what you can do with these. We have a new electronic setup that will allow you to actually put one cell next to another cell. Let's say you got 6 plates and then you have another 6 plates. Well, there's a way you can actually double your output by simply having more of those cells with our electronics. Right now you can't do that. So anyway, we appreciate you watching, and I hope I covered the gist of everything here, and we appreciate your support, and please visit our website and check out our new products, and we hope to hear from you later. Thanks a lot. Bye for now.